Could you talk a bit about the UK Mach 24 competition?
Yeah, so we heard about the Mach 24 competition, and obviously we want to do EuRoC. Like, that's our overall goal. But EuRoC is expensive. It's in Portugal, and that adds to transportation costs. And the requirements are, although they're very similar, the EuRoC. I'm sure you've read the EuRoC requirements before. They're a load of pages of requirements and what you exactly have to do. Mach 24 is a bit more lax. So like, it's build a rocket to 3,000 meters, carry a 1 kg CanSat to 3,000 meters as well. Although in Mach 24 it is harder in that we have to deploy that CanSat at the top of our, or it's not even at our apogee, but at some stage during the flight, which adds more complexity. But we have it's a bit easier for us to get over there first off, because it's in Scotland from Ireland. That's not an expensive flight in terms of transporting the rocket parts and just the people. There's also a higher limit on the amount of people you can bring. You can only bring 9 people to that competition. I suppose I think the EuRoC teams are like can be 30 big. I know certain teams have been very small, and as well as that, the actual just entry costs are just lower. So he said, we're a new team. We want to do something as close to EuRoC as possible, but we're going to go to do Mach 24. So 3,000 meters with a 1 kg payload that has to be deployed, and both of those have to be recovered. And then there's a whole raft of other kind of specific requirements. Most of them are centered around safety, like how well our fins can resist a certain deflection, a certain test we have to prove that we've done before we're allowed to launch a rocket on site. Yeah, that's the challenge for us really, is to design something that improves or like gives us a knowledge jump from what we've done on Shinna to what we're going to do on our Mach 24 rocket. Like, Sean, aren't we using a lot of fiberglass and carbon fiber? We're taking advantage of some of the facilities in UL in comparison to Shinna, where you're using this material called blue tube, which is kind of common for like hobby rocketists and hobby rocketeers in the US maybe, and we got recommended that by one of our mentors from the Irish Rocketry Society. But yeah, we're going for more exotic materials that will, the kind of materials we'll be using when we go launch in EuRoC,
We are really taking steps up in terms of our capabilities, what we can do and what we want to do. So we're looking at using a lot of composite materials, so carbon fiber for the lower section of fuselage, as well as fiberglass for the upper section. The reason we're using fiberglass over carbon fiber for that part is the interference with radio waves. Well, the interference radio waves you find in carbon fiber and metal fuselages, but the fiberglass will allow those radio waves to pass through, lower interference.
Stepping forward, even John Burke, you forgot about the CanSat. Dervla, you can talk about the CanSat we have in Shinna. So like, between Shinna and Mach 24, one of the differences is that because Shinna was always designed to be like, this is a stepping stone to a EuRoC rocket, we were like, we have to bring a CanSat in it. That was something that was really important to us. So now we're doing Mach 24. Like, Sean, you can say, I'll let you talk about your CanSat, Adam, and Sean, you can talk about your Shinna one, and Adam, you can tell us about what's going on in Mach 24. So now we're at Mach 24, we're like, okay, we have a proper CanSat, and like, the difference between that CanSat and what we have in Shinna, and then some stage at EuRoC, we're going to have an even more advanced CanSat. So it's a whole system step jump in terms of what we're doing in Mach 24.
Yeah, so the CanSat on the Shinna rocket, I would liken it to sort of like the Sputnik satellite, We're kind of just launching it up, seeing if we can receive the data from it, and that'll do us really. It's just a proof of concept like this, to see if we can do it, and if we can't do it, learn from the mistakes and learn from why we couldn't do it, Adam, would you like to talk about the fancier CanSat in Mach 24?
So in our Mach 24 competition rocket, we're carrying AgriSat, which is our 1 kilo payload. And the goal for this payload is to obviously descend and recover safely, but to intelligently map out the land below. So part of the Mach 24 competition is to have a sustainable mission and goal. So AgriSat is running AgriNet, which is one of our new sort of AI developments. And what it'll be able to do is understand the plant health and the irrigation paths of the scene below and intelligently stitch them together while using only low-cost hardware. We don't have the money for a very fancy scanner.
You mentioned the blue tube. What exactly is it?
Blue tube, if you've ever seen like phenolic that people would use in their like high-powered rockets, blue tube, I think the official word name for it is like vulcanized cellulite. So it's like this hard material. It's like, it's kind of like cardboard material, but it's much more pliable than say phenolic, but it's much stiffer than cardboard, and it's really tough. Like, tough is actually the best word to describe it. Like, and you can use it as if you were using cardboard or wood. Like, those are the kind of safety requirements. So you're not talking about putting on masks and stuff to cut them like you would with fiberglass or carbon fiber. But it's a really, really strong material. We've all had to import it in from the US, but it was an easy material for us to get started. It's like our Shinna rocket is just a monocoque design. Is 2 tubes with your central kind of E-bed middle and your payload at the top. We 3D printed our nose cone. So being able to just like get a really robust, easy to work with material that we can't really break too easily in trying to learn how to build a high-powered rocket, just suited us very well for us, and it's relatively low cost as well for what it is, And I know there's some really, really cool rockets that have been built out there using Blue Tube. And I think, Jamie, you're using Blue Tube again for Shinna 2, aren't you?
Yeah, we are. We're just going to use Blue Tube for Shinna 2 as well, because it's kind of to develop our experience in building rockets. And so going off kind of a new material and working with that would kind of be, I think, just a challenge, slightly too high for us, because, a lot of us are in first year. We've never built a rocket before. So yeah, we're going to go with Blue Tube for that, and hopefully have it go the same with Shinna.
What are your goals for the Mach 24 competition?
So I suppose we're trying to launch a rocket is the first thing. After that, we want to deploy a payload. And if all that goes well, we want to recover both of them. But like we said, one of the main things we're trying to do is develop our own experience in terms of like rocketry, high-powered rocketry, competition rocketry specifically. Like we could be launching 1 million rockets at home if you wanted to, big ones, like as big as Mach 24, but going to a competition and meeting new people, the operations of that, kind of being stringent on terms of like timelines we have to hit with Mach 24, PDR, CDRs. It does give us that experience that when we do go to EuRoC, whether it's this year or next year, we kind of have that knowledge built in. We have at the moment we've just submitted a PDR. We actually recently got feedback on that. The next month or so we'll be putting our CDR to paper, which will mean a design freeze. And in order to do that, we will have to start testing. I think we're very close to testing. One of our main goals, I think, with Mach 24 and how it differs with Shinna as well. I'm saying Mach 24, so I'm kind of referring to EuRoC as Mach 24 because it doesn't have a name yet, but it's to develop a non-explosive deployment device purely because black powder is not easy to get in Ireland, and we want to be able to test our rocket and especially our deployment system repeatedly, relatively easy, instead of having to go reach out to someone who has a license to handle black powder and meet on a certain day and test it. If we develop a non-explosive deployment device, we can test it 1 million times in our lab and know that it works and be confident that on the day our rocket or parachute to deploy and we'll be able to recover our rocket successfully. And hopefully building from that in Mach 24, all our future rockets will use this non-explosive device. Does anyone else want to add to that there in terms of what we're doing? I think, Adam, what we're doing on our payload is fairly ambitious.
It's a very kind of new thing. So we're building off some research that NVIDIA released. So they have it's called a general adversarial network for turning one image into a different image. And we're building off that model. And the goal is really to replace the need for using a very high cost spectral camera. And so we want to train a model that can turn the images from our normal camera into a synthetic version of something similar, but in near infrared. So yeah, it is a pretty ambitious project. And obviously all that data has to be stitched together afterwards. So other sensors we're using along with the camera, like the IMU and the GPS, are going to be really important there.